Okay, you have this worksheet in your packet. These are energy bar charts. We're going to be using these anytime we do problems dealing with conservation of energy, which we're going to be diving into soon. So an energy bar chart looks like this. You've got the three different types of mechanical energy at the top: EEL, EK, and EG. And really, it looks like a bar graph, but it's qualitative. It does say 0 here, meaning there's no energy, but we don't care about numbers. So we don't care about the quantity in terms of what the bars will look like. So all a bar chart does is tell you what kind of energy you have in certain situations. We will never really see just one bar chart. So in other words, these three examples that I'm going to start with have nothing there. However, once we get into conservation of energy, you're always going to have more than one bar chart. What we use them for, it's a visual aid to help you figure out what kind of energy you have at different points in a problem. So I'm just going to jump right into it using this. And again, you should have this in front of you. It tells you that a cart compresses a spring. You want to ask yourself the same three questions every single time you look at a bar chart. First, is there a stretched or compressed spring? So EEL, yes, there is. Second, is it moving? Is there any kinetic energy? In this case, no. The cart is just compressing the spring. It's at rest, not moving. And third, is the object above the base level? Does it have gravitational potential energy? If we set our base level right here, where the ground is, base level, then no, there's no gravitational potential energy because it's at the ground. So what does the bar chart look like? If you don't have any type of energy, you're just going to put a little dash to show that you didn't forget about them. So I'm doing little dashes under EK and EG, and then I want to show the bar under EEL. I went up 4 boxes high. It doesn't matter how many you go up. You could have done 1, 2, 3, or 4. All you're showing is that at this point, all of the energy is elastic potential energy. Next, we have a ball rolling on a level surface, so number 2. Is there a stretched or compressed spring? No. Is it moving? Yes. Is it above the base level? Again, if we set this as the base level, no. So a dash for EEL, a dash for EG. All of the energy here is kinetic. And again, does not matter how high I'm going with the bar. Next, it tells us in number 3 that, that a ball is at rest on a table. So ball at rest on a table, this one identified the base level right down here where H equaled 0. Is there a stretched or compressed spring? No, it's at rest. Is it moving? No. Is it above the base level? Yes. So we put a dash under elastic potential energy, a dash under kinetic, and in this case, all of the energy is gravitational potential energy. So that's what a bar chart looks like. Again, you will never really see just one bar chart. What we're going to see is more like the rest of this worksheet. So let's look at number 4. 4 and 5. So number 4 tells us that a pendulum swings from point A to point B. So we have a bar chart for A and a bar chart for B. At A, is there a stretched or compressed spring? No. Is it moving? No. Is it above the base level? Yes. So at A, all of my energy is gravitational potential energy. So I went 3 lines high. At B, is there a stretched or compressed spring? No. Is it moving? Yes. Is it above the base level? No. This is the important thing with bar charts. So I've said about 3 times already that you're never going to have just one. You're always going to have at least 2 for a problem. Because what you want to do is show where the energy is at A compared to where it is at B. Eventually we'll get into C and D as well. All that matters here is that however high you went with your bar in A, that's how high you have to go in B. So we have no elastic potential energy. We have no gravitational potential energy. I had 3 bars of energy in A. I need 3 bars of energy in B. So again, all that matters is the number of boxes high that I was in A is the same number of boxes high in B. You want to show that energy is conserved between part A and part B. Energy can't be created or destroyed. In these cases, it's not leaving the system. So number in A has to equal number in B. Let's look at number 5. A cart is set in motion by a compressed spring. At A, is there a stretched or compressed spring? Yes. Is it moving? No. Is it above the base level? If we make this our base level, no. No kinetic energy, no gravitational potential energy. All of this is elastic potential energy. Again, doesn't matter how many boxes high I'm going. At B, is there a stretched or compressed spring? No. What happened at B? What happened? A, the spring was compressed, it released the cart, so now the spring is relaxed. So there's no more elastic potential energy. Is it moving? Yes. Is it above the base level? No. So all of this energy from A started as elastic and became kinetic. 4 boxes high in A equals 4 boxes high in B. Go ahead and work on the rest of these 6 through 8. I'm just not even going to bother explaining them. I'm just going to fill them out, but I would like you to try them before you keep on going. Okay, so take a look at the answers for 6 and 7. 6 at A, it's all elastic. At B, it's all gravitational. 7 at A, it's all elastic. At B, it's got both kinetic and gravitational. All that matters with the number of boxes, again, it doesn't matter if I did 1, 2, or 2, 3, or 1.5 and 1.5. I had 3 boxes in A, I needed 3 boxes in B. If you had 4 in A, then you needed 4 in B. So if you have to split it up between 2 different types of energy, just make sure that the number here adds up to the number here. And here's the answers for 8 and 9. We've got at 8A, all gravitational. At an 8B, it all becomes kinetic. And then for number 9, it's all gravitational, becoming elastic and gravitational at part B. So it has gravitational number 9 in both parts. It's just a little bit less once it gets to part B because it's lower to the ground. So these are bar charts. We're going to be using these every single problem that we do dealing with energy. So make sure you know what you're doing with these, and I'm going to do more examples in the next video.